Good morning, good afternoon, or good night. Welcome to your lesson on Lewis dot structures. Now, the first thing we're going to do today is we are going to be talking about, first, a warm-up, a little introduction on what we're going to be doing, kind of asking about your prior knowledge about what's going on today. We're going to then, secondly, be going over the octet rule real quick. Spend a little 3 seconds on it. Third thing we're going to do today is talk about the electron dot notation right down here, followed by Lewis dot structures, what they are, what they do, and how to make them. And the last we're going to be doing today is practicing, and I have 2 activities for you. You can pick either one, either using a quiz game or an escape room. So without further ado, let's get into the lesson today. So for the warm-up today, I have 3 questions for you. First one is, what is a valence electron, and how many can you have? The second question is, how many valence electrons does Cl have? You're going to need a periodic table for that, so please click on the link right here. And lastly, how many valence electrons can He have? And does it still follow the valence electron rule? So let's guys pause the video right now and answer the questions inside your notes. All right. So warm-up is complete. We're going to go over those answers in 2 seconds. So for the first one, the octet rule. The octet rule refers to the tendency of atoms preferring to have 8 electrons in its valence shell. So that's that first warm-up question. How many do you have in your shell? Well, for most elements, it is 8. Unless if you're hydrogen. Hydrogen's weird because it can only have 2 electrons in its shell. Now, Cl can have a maximum of 7 valence electrons in its outermost shell because it's the 7th element in its row. If you count over the periodic table, it'll be the 7th one in. Or you can just look at the top group number and see that 17, just take that first number of 7 as your number of valence electrons. The last one we have to talk about today is He can have a maximum of 2 electrons in its outermost shell. But that's a-okay, because it's an exception to the rule. It can only have 2 electrons in our outermost shell because there's only 2 elements in its row. You have hydrogen, which is number 1, and then helium. So if there's only 2, you can't add more to that shell, so you only have 2 electrons in that outermost shell. This is our little quick review of the octet rule and how to use it and where we can find those numbers. So now let's dig into the meat and bones of today's lesson. The first thing we're going to do is how to represent a singular element and how to represent that with the electron dot notation of just the valence electrons. Then we're going to get into Lewis dot structures. We're going to see how those 2 electron dot notation models can now bond together and be happy. I know a lot of you guys have been doing a lot of bonding this past couple of months because of COVID-19. And now we're going to be talking about bonding again for our chemistry class. So for the first question, we're going to be asking, what is electron dot notation? Electron dot notation is a representation of an element in which only the valence electrons of an atom are shown. This is indicated by dots placed around the element symbol. Now you must fill up the space around the elements before doubling up. This is like if you're in a bus. If you're in a bus, do you want to be sitting next to somebody when you could be in an open seat? Most time people would say no. They would rather sit alone. Same thing stands for the elements. When they have electrons, the electrons like being by themselves and being alone before doubling up. So we're going to work our way around the element before we start doubling up in those spaces. Now, how can we draw the electron dot notation for oxygen then? I'll show you that right now. So a couple of steps we're going to follow with electron dot notation, how to draw them. First, we're going to write the symbol of your element. In this case, we are using oxygen, which has a symbol of O. We're then going to determine the number of valence electrons that it has by its group number. Again, we're going to look at your periodic table, and we're going to count over to the oxygen point, which is 1, 2, 3, 4, 5, and 6. So there's going to be 6 valence electrons, or we can just look at the group number here and know that 16 is its group number, so it's going to have 6 valence electrons. And then what we're going to do is we're going to add dots around our element symbol until we get to 6. So we do 1. I always start on the right. You can start on top, bottom, left. Doesn't really matter as long as you start there and work your way around. I always go counterclockwise as well. So I do 1, 2, 3, 4 on bottom, 5, and 6 on top. Notice how 5 and 6 double up after everything has filled up. That's important because that's how all electrons configurations will be working. Now I want you guys to practice 2 of them. The 2 I want you to practice is how would you write hydrogen as your first one. So looking at your periodic table, find out how you can write the electron dot notation for hydrogen and also Ca. So again, the 2 you're going to be doing is writing hydrogen and also calcium, Ca. Alright, so for the answer for hydrogen is H with 1 dot because hydrogen is the first one there. Calcium has 2 dots around it because it's in group 2. And it'll look like this. If you want more practice on these, there's going to be a link labeled right now that'll give you a little bit more practice on these. So now let's talk about Lewis dot structures. So Lewis dot structure is a simplified model to represent just the valence electrons of an atom when they bond. This is important that we're going to be talking about when they bond. A Lewis dot structure is an electron dot representation which replaces the shared electrons with lines to indicate bonds. Note that these bonds will only occur with covalent bonds. It's not ionic that this happens because in ionic you gain or lose, and we're sharing here. So if you're sharing, you need to be covalent. So how we're going to show this is with 2 of them first. I will show you guys these, and then we're going to talk about how we are going to go about solving them. So the first one is F2. We would first draw our F with our dot notation around it. And because there's 2 of them, we just put 2 of them together. Then what happens with these elements is they like to form their single electrons that are by themselves with each other so they can share them and be happy. In this case, fluorine is sharing 1 pair of electrons. So we replace these 2 dots with a line, and we call that a Lewis dot structure. The same thing can be said about CH3I. These electrons that are being shared are going to be replaced with 3 bonds, right like that. Now you'd be asking yourself, well, how do I go about doing these? What steps do I need to do to get there? And I have a way in 6 steps you can get these right every single time. And this is how we are going to be doing electron dot structures. Now I'm going to explain to you how to do it first in words, and then I'm going to have a link with the practice that'll go with you step by step of how to set this up and do them. So the first step you're going to do is write the formula without any subscripts. Then above each of the elements, you're going to write the group number it is in. This will tell you how many electrons are available to it. Below each element, you're going to write the number of electrons needed to fill the outermost energy level. In number 4, we're going to box the element that needs the greatest number of electrons. This will be the central atom. We call the other elements the other elements. The next step we're going to do is we're going to write down the central atom and bond the other elements to it. The number underneath each element tells you what kind of bond it's going to make. If you see a 1 underneath the element, it means it's going to have a single bond. And a single bond looks like this, where you have one singular line connecting the two atoms together. A double bond, much like how it sounds, is going to be 2 bonds, 2 lines between those elements. And the last one, a triple bond, is going to be 3 bonds connecting the other element to the central atom. Now you can always check to make sure all elements have 8 electrons by circling them and counting up the number and seeing if they have 8. Remembering that each one of these bonds has 2 electrons to it. So single bonds will have 2, double bonds will have 4, and triple bonds will have 6. Now here are 3 examples I want to do with you. We have CH4, NOH, and N2, as well as 3 more practice ones you will have in your notes. So if you can please click on this link to your side, right on the side of your screen, right over here. You can get linked to me walking you through each of the steps and showing you how to solve them. Again, they'll be right over here. All right. So welcome back to our notes. We have one more thing I want to just introduce to you before we end for today. The last thing I want to talk to you guys about is sigma and pi bonds. Now, for sigma and pi bonds, this is when 2 elements have 1 bond between them. We call that a sigma bond. Every time we form 1 bond together, that is a sigma bond. After the first bond, every other bond we will make is called a pi bond. And no, it's not something you can eat. As much as I would love to eat pi bonds, they're sadly what we call them. For double bonds, you'll have 1 sigma bond and 1 pi bond. And for a triple bond, you'll have 1 sigma bond and 2 pi bonds. Please make sure you will always have a sigma bond first. And there will only be 1 sigma bond between 2 atoms. You'll never have more than 1 sigma bond. So that concludes the notes for today. Now you're going to have your choice of the following. And you're going to have a choice of either playing a game with 2 answers. You can play the same game that's 1 minute long questions. Or if you're going to really challenge yourself, there's the quiz with 30-second questions. Now, if you get done with this and want to try something else, you can also try the escape room, or you can just try the escape room by itself. In this, you're going to be given a maze you're going to have to make yourself out of. And you need to find the right answers to get to the end. And be careful, because you want to keep those number code rooms, because that's going to get you out of your room and be the answer to the lock at the end of the door. So if you have any questions, please feel free to email me or contact me whatever way you can. I'll be more than happy to answer any questions you have or elaborate on any of the concepts listed today. So looking forward to hearing from you guys soon, and have a great day.